All right, so I'm back, and this is part two of the last video was about convince me to open source something. I want to open source it. So far, pretty much I've only attracted trolls to the project, um, but maybe that's because I'm not. Well, for one, posting it in the right places. But the other question is, have I really explained the value of this thing? Because so far people have called me out on like dumb stuff that when I just read it I think, wow, what an immature programmer, or what a very simple question for something that's not simple. I think it's better if I maybe go into some more details about the various things that it does, but there seems to be this assumption by at least one person, possibly two, that it's an embarrassment for me to release it as open source. And I don't think so. The reason why I don't know if I want to release it as open source is not for that reason. It's because what good will it do if it just sits there, or if somebody plagiarizes it, or if it just simply, you know, dies. Like, I want people to take it, and like I would make tutorials for it, and I would work on it a bit if anybody cared about it. But it sounds like so far nobody gives a rat's ass what I do or have done, or my career, or anything that it's been valuable for. And they'll just make these like insults towards the project right from the jump. I'm not even sure what the motivation is other than to bother somebody or to get a reaction. Or perhaps they're just immature people. I don't know how old they are. But this is a lot of different things, and I'm just going to go through and highlight and talk about why it is what it is and what it's good for. You still may not care, you still may scoff at it, but in the end, I don't really care. It's just something that I wanted to share and thought that other people might be interested in. If they're not, I don't want to say that nobody is, because it's just the 5 or 10 people who have like bounced through from Reddit or Handmade Network. Uh, so, whatever. I mean, they aren't representative of everybody or anybody who would actually care about this. So first of all, this is not an innovation in the respect that it does do new things. There is totally unique code in there, but somebody pointed out like, oh well, it sounds like you're not doing anything that nothing else, like you haven't invented anything. There's nothing important in there, but they don't know what's in there, so how could they make that judgment? But an example is like somebody said, "Oh, great, you can draw a line in a circle. Who cares?" Well, it's the way that it's handled, and it's also the fact that I took the time to implement the most comprehensive circle line collision test possible, so that you can do, basically allows you to do pass through. So if a bullet passes down this line, hits you, hits the circle, and then passes out the back, you know where to, and the angle at which to eject particles, so that it looks like you've blown the brains out of the zombie. That's yeah, I that's math. Code is not math until you tell it what to do. I mean, it's from math. It's from just the fact about segments and circles and projections and lines. But the fact that you get that already written for you means you don't have to go and research that and write it. All you have to do is create a circle collider and then pass out a line, and then it'll give you back a distinct set of return data. I'll give an example of that since I do have the screen up here. Circle is a part of the trigger classes, series of classes that. Well, let me look for box real quick because circle's not coming. All right, box 3D box. Is that it? No. Well, I'll just type trigger in. Okay, so you have your circle, and then it comes back with your segment. So, I mean, when it collides with a circle, you get a line that includes the 2 points that the circles, because two circles, when they come together, there's a line that describes where they're colliding. It's just more advanced. It's just so stupid. Also, drawing a circle or a line is non-trivial in OpenGL. It's not something that you just say, draw my circle for me. You probably have to pre-compute a two-dimensional VBO, and you probably want that to be somewhat programmable. You want to have, color interpolation on that. You calculate these points. Maybe you want to apply a texture to it, but I have that stuff too. It's in there, and it generates circles, and circles that are solid and circles that are outlined, and you can set various parameters of that. You can do an ellipse. You can, do a line with a rounded end. Those are things that, again, non-trivial, and just one of many features that are, embedded in this that I would, I guess, make tutorials for. It's got skybox handling. It's got multiple skybox handling. It's got ways to handle cube map spheres as skyboxes instead of the cube to correct for certain distortions that occur in a cubic skybox. It's got ways to generate a variety of different cylinders and cylindroids, other types of cylinders, tubes, cones, tapered cylinders, which is a cone with a segment cut. All the things you would need to generate primitives. If you wanted to, from primitives, something more complicated, you could compile them all into a single VBO, and then you would have that. You can apply different types of texture mapping to it. You can apply different types of color per vertex color if you wanted to use that technique. It's got things to display. All the major, Fong, Tune, all that stuff is in there. You can just maybe go through that list if you'd like. But let's talk a little bit about UI before we get to shaders. So I was a user of processing, so I created a kind of in-engine framework that is nothing like processing itself, but it organizes things. Basically, when I was working on processing IDE, I had to make a complex graphics tool in processing once, and I found myself writing many classes that had like a draw and a loop in them. And then when I got to Asir, or Ikari, or whatever it is, this other language that's built entirely around graphics, it had a lot of render and between. And I saw that pattern in other things where you have this render clause and then between frames, or the frame call. That's like all the calculations that are happening between the render calls, so that you can do real-time manipulations, updates, whatever, once per frame for every object on the screen. Between gets called, then render gets called, and it's usually in separated, distinct layers, right? So all this stuff is figured out for you. All you have to do is create a processor object, and then create a child of the processor object. For instance, here we have that one called a cool button. All right. So early on in this project, I wanted to make like the ultimate button that was like animatable, and so cool button is that. You can assign it various colors, which is the crayon class, and then you can assign it. You can give it a string for its label, and you can provide it a sound for its click and for when you hover over it, so that it can go like glue, click, that kind of thing, because it's a game engine, and you're making fun menus. You can stick an image in instead of text. You can define how big it is. Basically, a processor object is sort of like, it's hung off of a processor's collection, which is called in your render in between for a window that you make in this, and And so this is the smallest, most atomic component. And the processor class is pretty complicated yet simple. Like you create a child of it, depending on which of the virtual functions you choose to override, you can attach it to one or more different processor objects, processors collections. One is the very simple one where it just like you give it a list, it goes to the list and executes everything in the list. That's simple. But then if you wanted to do like a big world and you wanted to do off-screen de-emphasizing of entities, there's one called a zoned processor. So what that does is it defines a grid that's tuned to 1080p. So each grid space is like 2 times the size of the screen on 1080p. And I think these are adjustable, but that way anything that is off the screen at a certain distance is not going to be computed, but its position will be updated as the player moves around in the world. And then when the player leaves the zone, he enters into the next zone or set of zones. Because, for instance, if you set the zone smaller than a screen, instead of it executing on one list, it's going to execute on all lists that are at all partially visible in those zones on that screen. So this is an optimization that allows you to have literally hundreds of thousands of objects in a world, but only a single area that's active at a time, which is commonplace in platformers, in top-down games, even in 3D games, although you never see it. It's not based on the screen position, it's based on the far value. But regardless of that, it's like a 2D world that can move into forever. It can go on for a very not forever, but can go on for a very large space, probably larger than you would ever need if you did want to make it that big. But you can limit the size of the world however you want. So there's that version that hangs your processor. What is a processor? Processor is it's not called an entity. It's not called a sprite. It's not called a window. It's not called a thing. It's called a processor because you not only use them for entities and sprites, and I guess entities is the correct term. You don't just use them for entities in a game, but you can also use them for just a graphics thing or a whole window or an overlay or something that you attach to something else. It's just a general term. A widget would be another word for it, but processor. So the processor has a controller class in it that allows you to have like scriptable variables. It's got and to control values over time, so you can put a variable in there and then give it an easing waveform, also known as a tween. You give it this tween and it'll iterate that in some way, and then you can update that controller every frame, and that'll give you a new value to play with color or size or whatever. And then it has its expired duration and delay. So if you have so you can use this to make a linear movie or to delay the creation of it. So, if you the movie itself, the processor's list, or perhaps your window that's in, has some sort of value of how much time is expired, it can use that time limit to set a delay. So, or not even that, just as it's going, when you have a processor, you can set a delay of 1 second. It won't go to its first frame until a second has passed. It has a duration which is like 10 seconds. So from the moment that the delay ends, 10 seconds, and expired is the amount of time that's expired. Delay plus duration is that full end. You can use these are all calculated whenever you do between, or they're written there so that you can write the logic there when you're writing your between, but they're very common values that are used all the time. That's what this is all about. It's for all of those different use cases. And then it's got its collision, so that you can provide it with a collision object, and that collision object is smart enough to know what to look at, where to look at it, what does it collide with. And, I can provide examples of this stuff later, but that's just an example of what a processor is used for and a button is one example. A particle, a whole particle system could be a processor. You could have it be an entire menu, or you could have it be a single button or a slider or part of a slider. It's really up to you because you're really taking your work and dividing it up. And this is what processor, it's saying a slice of a processor. It's a CPU side way of sectioning out a little bit of compute for your graphics program that you're making. So some of the boxed ones that are in here are like circle menu, film, which is essentially a series of textures that are played in order or in some order based on time. You've got a fire and forget. So this is a type of processor subclass that's used to create additional subclasses. And these are fire and forget, so you don't have to worry about their disposal. Processors don't get automatically destroyed. So if you had a fire and forget processor and you added it to a fire and forget processor viewer, then that viewer would automatically know when to delete it when its duration was over. Sometimes you don't want processors to end, and sometimes you don't want them to end when their duration is up. So, this is a way to get out of that constraint, and so they're called it's the family of processors called fire and forget. I use that all the time for making you can see examples like a puff of smoke, a cinder, other things, a spinner, a film trap, and a film rotated rect. That's actually a film trapezoid that's spinning. Why is it a trapezoid? Well, it's a grid. It could be a triangle or a trapezoid. I use this, for example, to do like a spotlight coming out of a spaceship, right? In 2D is one example of where you would use that as a triangular trapezoid, where one end of the trapezoid is essentially 2 points are in the same position. So you spin it out and it you set those two values the same and a trapezoid becomes a triangle. A spinner, which is just a spinning object, and you can set its position and stuff. So then I wrote other versions of like the spinning expander, or the just very generic. You can give it some sort of for instance, like a graphic of an explosion, or a puffball, or a fireball, or a piece of broken ship, a rock, a blood spatter, something like that is going to spin and expand as it fades out. You see these kinds of effects all the time in games, but that's just one example of a family of processors. There's all these different approaches to lightning. So there's some lightning in there. There's some, just general stuff you need, like something that just fades in to make a movie. So you can take these processors and you can put them into a slide, which is a processor handler object that fits into a presentation. And this allows you to make an entire movie. Things are fading in, maybe there's some text, a ship is moving. All those cutscenes that you see in games that are simple yet compelling enough to tell the story. It's all what art you put in it, so it doesn't really matter what it looks like in the examples. It can be anything, and there's a way to do it. It's as powerful as, say, Flash was, or Director, Macromedia Director, or like PowerPoint, or just simple GIF kind of meme. You could make those sort of things in there. And then you can display models, and you can generate models and display the generated models. And I am deprecating multi-point sprites and point sprites because we don't. I think I've removed all of the display list stuff, but there was some display list stuff in here a few years ago to create some of the effects that you can do with that. But now you can do them with a shader, so who cares? You've got like an integer selection widget, like all these widgets. You can display a shader in an area, and it's just to control a whole bunch of different tiny like mini scenes at one time. So with this, I made a starship fighting game where each, the starship had its own custom rendering, and then it was layered in a layer of other ships, and those ships, could shoot at each other. The bullets were processors, the ships were processors, the player's ship was a processor. It's just a way to think about a piece of graphics on the screen. So you could think of it as an entity, but once you say entity, it sort of means to a game developer, oh, an entity. No. This is just even proto-entity would be a good name for it. But I called it processor because it was sort of inspired by the processor, or processing IDE. I think another thing to point out is that it does react to mouse and keyboard. So, you can do all of that in there too. So each one is like its own little sketch, and that sketch can, be manipulated by whatever you want, including, the player input. So here's an example of and then there's ways to group processors so that, like, for instance, when you're doing like team-based combat, you need 2 groups or 3 groups or 10 groups. And if they're all fighting, they need to know what group they're in. So an easy way to do that is to create a group object, group the processors, and you can also do things like remove that entire group, add this entire group back, that sort of thing. So then the linear presentation and slide classes are here, and it's all been figured out. Like you rewind it, it can do letterbox, it's got a pause button, you can roll it back, it's based on time, it calculates the deltas all the same for time, it's designed to be played and rewinded and I believe even played in reverse. I'm not sure. I think there is a way to. The problem with playing it in reverse is some of the things don't work right, but it's up to you. You have to respect reverse or respect rewind or not. So you're writing different processors for different reasons. And then in the presentation, you can respond to the mouse. You can do all sorts of things. And then there's this thing called visual aid, which let's see here. Like the visual aid just kind of wrapped up a whole bunch of like processors that I was working on that had common functionality. So it's a maximal and generally useful processor, and it uses these controllers. So this is where it's sort of like a programmable object. You can tell it to, start small, get big. In fact, I made an editor that uses it that allows you to just make presentations, and that's a part of 8. So, maybe I'll give that away with the source code if I decide to do that. But certainly including that might be useful for some people to understand what the hell's going on. But, it lets you control the color, the placement, and the size, and the, opacity of an image is all it basically does. And that's what visual aid is all about. But it has lots of features baked in, like what angle and how that angle would change and things like that. So these are like the lowest level things, but we're working our way out from that. So this is where you would write graphics stuff, like draw a line, draw a picture, play a sound, things like that. It's like a multimedia thing. And then you have the collections. And those collections and anything else you write falls into something called a GL window. And I'll show you a little bit about that right now. So a GL window is essentially, it's like a windowing system that doesn't have as many constraints as like windows do. And these are windows inside of a GL view. So you have your manager, which is global, it's called Windows. And then you can windows.add a GL window child to it. And a GL window child takes or implements in the abstract class GL window all of the various things that you want that window to be aware of and to do. So you might include a processor list in that window and then render and update it so that you could have that processor be an aspect of that window. So an example would be like in 3030 Death War Redux, there's like a part where you're on a screen and you're choosing your next mission. And there's like a scroll view in that. There's a background picture in that. And then there's like little bugs that are on the display that are like a layer above everything. So you could do all of that in a GL window, but you would write those parts in separate things. Like you would create an insect processor that you would click. Like maybe it would randomly fly away, which is what it does in that game. Maybe it would, you click on it, it falls or gets splattered. That was the whole thing in that game. And then you would use a FX list processor thing that's in there, which is a framework for the effect of a list in a scroll window with a scroll bar. You know, you have all those in like a UI list. So there's a second layer. And then your third layer would just be displaying an image in the background, which happens to be a picture of a terminal that you're drawing on top of. Now you can, do whatever you want. You don't have to align it that way. But that's how you would make in this engine, in a GL window, you would make that panel from that game. Because the games are divided into panels. So you have your main view with like the overlays, and then maybe you have like, I don't know, a stat screen or a dialogue panel where you're talking to an enemy or a friend or whatever. Or you've got, maybe a store and an inventory panel. So you have all these different panels in games. GL window is where you would make one of those panels from all of the other little parts that I was just describing to you. So to give you an example of GL window, all you have to do is go into the tests, and you can see, like, here's a GL window GL test. That was like a camera test from a while back. Let me see if I can find. Well, here, Fluid 3, is that working? Yeah. So how did this come about? How did this test case come about? Well, I started with a GL window, and then I included a file called Fluid 3D. So if I go into Fluid 3D, okay, so here I'm implementing a trackball mouse feature that works with some attributes. It looks like this came from a tutorial or some free software, or I wrote it based on some free software that I read about. And it's got all of these features kind of baked in to this, and it's got some GL helpers, and it's just its own thing, right? But it's made to work with a GL window, so it's made to write to an FBO, and then that FBO can be displayed here, and that's probably happening in the render. So this kind of pattern where you include something you've written, which has all the functions that you need in it, and then you write a between in that, and you write a render in that, and you write an init in that. And then you call them in these are like the three most commonly used virtual functions of a GL window, which would be onload, just like JavaScript, between, which is between a frame, and render, which is called during the rendering pipeline. So then you take this window, you instantiate GL or Fluid 3D test, and you include that in your Windows in the load, you do windows.add new Fluid 3D test, and that will add it to your window manager so that when the window manager is done initializing, it will display your window. And GL window has lots of little features, like I can anchor it to a certain percentage of the screen, or I can set explicit resolution information there. I can pick the background of the window. In this case, I picked indigo. I can do other things like make it invisible by setting its hidden flag and stuff like that. So getting to know and playing with the features of GL window is probably one of the first things you would want to do. Aside from that, also getting used to the idea of creating a processor and either using the processor directly by calling its render in between. You can think of really anything is like that. So you needed in C++ to name things distinctly, but what it really is you've got this atomic level thing that's replicatable and is an object on the screen. That's a part of a list, and that's a part of a window, and the window is a part of a window management scheme. And that window can have a 3D object drawn on an FBO, for instance, an entire 3D scene drawn on an FBO, and then you just display that FBO. But the idea that Fluid 3D is essentially like a processor, because there's only one of them, it's a singleton, so in this example. So you can treat a processor like that. So I guess I could, right now, create an example of all of that in one place. So yeah, but that would be making a tutorial, and I'm not looking to make a tutorial today. But anyway, so I don't know. So far, asking the question to the internet, should I open source this? Not very promising. Just haven't maybe found the right people yet, but it's disheartening and it's difficult. People are mean. They make blanket statements. It seems like some of them are only talking just to talk, and others are just being negative. In fact, I would say probably at least 50% of the people who have responded to all of my different posts on different forums and places like Reddit have been negative. And negative for reasons that obviously the reasons they gave show me that they didn't really understand what I was saying, and I don't expect them to necessarily know everything about it, but without knowing much about it, they dismissed it. And so the point of this video is to give people a little more information, because apparently I didn't do all that well last time. Although for me, it's like, I know it's in it, and I know why it's good, and I'm happy to continue to show that to people until somebody says, yeah, I want to help you with that, Well, thanks for your time. If you've gotten this far, you really cared. And I hope you have a great day. Get back to me if you're interested. Peace.